Welcome back to BSpice. In this session, we'll discuss about cyber vulnerabilities in industrial protocols. So in the earlier video, we talked about the cyber vulnerabilities in industrial control system. Now we'll focus on about the vulnerabilities in industrial protocol. So industrial protocol in the sense, this DNP3, that is about distributed network protocol. Then we have MODBUS, okay. Then we have a MODBUS, then we have a IEC, okay. IEC 61850, IEC 61400, and 60870. All these will focus. And of course, the IEEE also will focus, which is C37.118, which is not shown here. Then apart from that, message queuing, telemetry transport, MQTT, and of course, the universal one, OPC. We talk about all these in this session. Okay. So, of course, we are going to discuss about the vulnerability, but predominantly we talk about the features, all this in this session. Okay. So, yeah, as I said earlier, the agenda is Distributed Network Protocol 3, that is DNP3, and Modbus, IEC 60870, IEC 61850, IEC 61400, IEEE Threat 37.118, and Message Queuing, Telemetry Transport, MQTT, and finally we wind up with Open Platform Communication, OPC. Okay. So, just want to also a bit of an intro here. Friends, with the existing system integration, what is the primary function of ICS? ICS is to gather real-time data, right? Realize device automation, right? And supervise the entire system, right? So how this is achieved? This is achieved through a number of communication protocol, right? So like, DNP3, Modbus, IEC, all these, right? Okay. So in this first one is the Distributed Network Protocol 3, DNP3. So basically, this is an application layer protocol with multi-tier structure, okay, with primarily used in grid application and smart application, okay. So DNP3, friends, is an internationally recognized, what do you call, a recognized standard actually. What for? To ensure dependable data transmission and support functionalities for ICS, okay. So basically this DNP3, when we talk about DNP3, it actually incorporates, enhanced performance architecture. We call it as a EPA. Basically, EPA in the sense a streamlined version derived from the OSI reference model. I hope you know this OSI, right? Open System Interconnect. Okay. So DNP3 typically operates over the TCP protocol and assigned to port 20,000, just for your info. Okay. And of course, it adheres to the what do you call client server model. So the master which performs client function and the slave which carry out the server function. Okay, you got it? Right. So what else? Okay, when we talk about DNP3, there are three layers we can talk: data link layer, transport layer, and application layer. Okay, I will talk one by one. So data link layer is nothing but it is responsible for sending and receiving frames and header information and contains header information such as source DNP3 address and destination DNP3 address. So that is a simple thing. So basically this is responsible for sending and receiving frames and contains header information. At the same time, this is also responsible for calculating errors through cyclic redundancy check. Okay, checking the link status. Then the second is transport layer. Okay, maybe before talking to the transport layer, I'll talk about the application layer. This application layer creates a message to be communicated. Okay, create a message to be communicated. So in the transport layer, this actually what it does, it actually fragments. It fragments the large packets received by the application layer. That's it. It fragments the large packets received by the application layer. Just to make it very simple. So data link layer responsible for sending and receiving frames, right? Okay. And contains header information such as source address and destination address. Okay. Application layer creates a message to be communicated. Okay. And transport layer fragments the large packets received by the application layer, just for your updates. Okay. Then we move into the Modbus. As you all know, this Modbus was initially created in 1917 by American company Gol is an openly available communication standard designed for enabling the communication of PLC. Right, friends? So here, with Modbus, a master device can efficiently exchange data with multiple slave devices. So that is the concept. Okay. But theoretically, every node on the network can transmit messages. The most common for communication to be instigated by the master device, right? So the Modbus protocol become the most widespread protocol for communication between control devices and industrial automation system. Okay. Right. So this is about a simple, talk about Modbus, but the main thing will focus actually, on the types actually. There are three types of Modbus protocol, right? One is the Modbus RTU. So basically, it is a widely used communication protocol, right? So it is actually designed for serial communication over RS-232 or RS-485 interface. Okay. So this is very simple and efficient in transmitting the data between the devices such as PLC and sensors. Okay. When we talk about the key feature, again, this Modbus RTU uses serial communication, can be transmitted over RS-232 or RS-485, allowing for long distance communication and of course with noise immunity. So Modbus RTU follows a master-slave architecture. Okay. So master device, that is a PLC or HMI, initiate request and slave devices respond to the request. So that is how. Then when we talk about the communication, RTU, Modbus RTU is based on frames or packets. Just remember, frames or packets. Okay. So RTU supports various data type, including binary, discrete inputs, input register, holding register, all these. So master device typically poll slave devices by sending requests for data. Okay. This polling mechanism allows the master to request specific information for each slave device. As we all know, Modbus RTU is known for its efficiency and speed in data transmission. So it is suitable for real-time application. Just remember that. Okay. The next one is a Modbus ASCII. So this is another variant of Modbus community, right? So like Modbus RTO, it is also designed for serial communication, but thing is it employs a different encoding format. Okay. So this Modbus ASCII represent data using ASCII character, which makes it more human readable than the RTU actually. Okay. So Modbus ASCII is a character oriented and each character is transmitted by a single byte. That means 8 bits. Okay. So this is, more suitable for system where ASCII based communication is preferred. Okay. So that's about the ASCII and a few more to add on actually. Modbus ASCII devices can often communicate with Modbus RTU devices with proper configuration and protocol translation. So that possibility is also there. Okay. So another advantage point of view. So it actually Modbus ASCII format of Modbus ASCII frames make it human readable, as I mentioned, right? So which can be advantageous for troubleshooting and debugging purpose. So that is the another point. Then we talk about Modbus TCP. So this uses the more modern Ethernet communication, as we all know, and is frequently employed in industrial automation systems. Okay. So Modbus TCP operates over standard Ethernet, allowing for fast and efficient data transmission. Okay. So it's again Modbus follows a client-server architecture. In this setup, the client devices, that is PLC or HMI, request data from server, slave devices, and server responds to the requested information. Okay. And Modbus TCP uses a standard TCP IP communication protocol. Okay, friends. So unlike Modbus RTU and Modbus ASCII, this Modbus TCP uses character-based frames. Character-based frames. Okay. So whereas sorry. I think there is some mistake here. Unlike Modbus RTU and Modbus ASCII, which use character-based frames, both Modbus RTU and Modbus ASCII use character-based, but Modbus TCP use binary frame. So that is the point here. Okay, that one also remember. Basically, each frame, friends, when we talk about frame, it consists of transaction identifier, protocol identifier, length field, unit identifier, function code, data, all these actually. So this format allows for efficient data transmission. So that is the point. So you can make out easily which is best. So TCP, Modbus TCP offers a high-speed data transmission, making it suitable for real time, whereas ASCII is not possible, right? Yes, that is the point. So that's about this. And yeah, of course, when we talk about the vulnerabilities, the researchers actually have proposed the Modbus TCP security protocol, which incorporates authentication and authorization mechanism. What for? To ensure protection against deliberate unauthorized access as an enhancement of improved security in the ICS framework. So this is about some of the aspects in Modbus. Okay. So we covered DNP3 and we covered Modbus. Now we'll go into IEC. So let us start with IEC 60850 part 5104. So basically this is an unencrypted protocol, meaning it transmits data in plain text without any authentication mechanism over TCP IP. So that is the challenge here. So this IEC 60850 part 104 Part 5104 is an international standard providing communication standard between SCADA and substation. Just remember, friends, 60850. SCADA and substation. In transmission, the application layer of this protocol conveys an application service data unit. We call it as ASDU. Okay. So this is about a small notes on 60870. Then when we talk about 61850, it is again a collection of communication norm that outline protocol for designating devices, data, communication system linked to the automation of electrical power substation. You got it? So basically it's related to automation of electrical power substation. Basically, this standard 61850 presents guidelines for establishing best practices in substation engineering. Always remember substation engineering 61850, encompassing protection, monitoring, integration, metering, testing, all these aspects. Okay. So within the domain of substation automation, the need for high-speed communication is very much essential to meet the data transfer rates, right? Isn't it? Yes. So this IEC 6150 delivers services, protocols, and a structure engineered to streamline the modeling and communication of intelligent electronic devices. We call it as IEDs, right? Yes, that's the use actually. Okay. Again, this substation communication system is divided into three layers. IEC 6850. One is the process layer, second is the interval layer, third is the station layer. Okay, I think I didn't put it here. Yes, the interval layer. Yeah. So process layer includes various primary equipment and intelligent electronic component, realizing a major function of smart substation. Okay. The process layer within the substation involves gathering the data from transformers, transducers that are connected with the primary power system processor. Okay, so this is the process layer. Then we have an interval layer. This includes the secondary devices like, relay protection equipment, control devices, and it actually functions as a barrier between the other two layers, meaning process and the station control layer. That is the interval layer. Then we have a station control layer. This layer primarily handles monitoring and management of intelligent station, enabling comprehensive measurement and control capabilities for the entire station. Okay. So I hope this is also useful. Okay. Then we talk about 61400. Okay. So this 61400 is specially designed to communicate them WinForm supervisory system. It is extension of 61850 standard in wind power generation. So the basic purpose is to provide network communication standard between WinForm supervisory and other substations. That's it. As simple as that. Okay, friends? You got it? WinForm. Okay. Now we talk about IEEE 6 C37.118. You know, friends, in substation, this protocol is commonly used to establish synchronization, right? So, and it defines the standards of data transmission formats. It outlines actually four distinct messages. What is that? Data, header, configuration, and command. That's it. So basically, this IEEE C37118 outlined four distinct message types: data, header, configuration, and command. So in typical transmission process, these messages are converted into frames and yeah, so this is what is happening actually in this C37.118. Just remember that this is used to establish synchronization. Okay, right. Then the final one, or not final one, the other one, MQTT. We call it this as a message queuing telemetry transporter. See, basically, when we talk about this description, so this is basically a lightweight publish subscribe messaging protocol designed for the low bandwidth. That is the point. High latency, that is high latency or unreliable network. So it is used in IoT application for real-time communication between devices and system. As I said, MQTT is a lightweight nature, right? So it's more suitable for resource constrained devices. So MQTT can be vulnerable to, what you call. There are some terminology which I'm not sure whether you are aware. See, this MQTT is vulnerable to eavesdropping, man-in-the-middle attacks, and unauthorized access if not properly secured. I'm going to talk about these terminologies of cybersecurity in one video, okay, after this session. So there I will explain all these, what is man-in-the-middle attack, all these, okay. So that is the point actually. So to sum up, it's a lightweight subscribe messaging mod protocol designed for low bandwidth, high latency or unreliable network. Okay. With that, I would like to end this MQTT. Then I will move on to the final session of this video, OPC. In fact, on OPC, we talked about in detail in our BSpace channel, including the question and answers. So you can watch and get benefited. So here I want to touch upon a bit. See, as you know, OPC is a set of standards for industrial communication, right? It plays a crucial role in Industry 4, which focus on automation and digitalization of manufacturing process. Okay. The main point is, friends, this OPC actually, what do you call this OPC enables the interoperability of devices, equipment and systems in industrial environment. So it includes various specifications such as OPC data access, DA, OPC unified architecture, UA, etc. Okay. Alarm and events, HTA, all these, historical data, all these. Okay. Right. So here, when we talk about the vulnerability, common threats include data interception and unauthorized access, and of course, the denial of service attacks. This also we are going to talk about the next video. So OPC UE in particular has a robust security feature, including authentication, encryption, and authorization, making it more suitable for industrial communication. So this is the typical structure. As you can see here, this is your network, this is your OPC client, OPC client or OPC client, and this is your standard, the DCS system, and you have the process actually. So I'm not talking about this OPC here in detail. I only touch upon the, vulnerabilities. Okay. So vulnerability in the sense, it like data interruption, unauthorized access, denial of service attacks, all these actually. Okay, friends, you got it? Right. Yes, that's it. I think what else I can talk? I think I'm done with that. Yeah, maybe I can touch upon a bit. Friends, just before winding up, um, yeah, we know that ICS integrate both cyber and physical subsystem, right? So it possesses inherent vulnerabilities, right? Which is, susceptible to attacks from both internal and external sources, right? So every form of threat can have a catastrophic consequences for power system, right? Right. So it is widely acknowledged that cybersecurity typically involves aspects such as authentication, authorization, encryption, confidentiality, and integrity and availability. Okay. So I will just wind up with this aspect, Sam. See, when we talk about the confidentiality, unauthorized individual can exploit this vulnerability to access confidential information. That is one we have to, avoid that. Then availability. In the event of availability loss, the system could forfeit its capacity to maintain control, resulting in substantial economic losses. You got it? Right. When we talk about integrity, when we miss or a corrupted data packet is received, when a missing or a corrupted data packet is received, it renders the entire transmission process ineffective, isn't it? So it causing, significant disruption to the normal operation. So this is about the integrity. Then when we talk about the authorization and authentication, malicious actors may exploit this vulnerability by manipulating the function code to send arbitrary data to others. Yeah, so prominent protocols, lack authentication mechanism for verifying identity and making it for easier for the unauthorized party to obtain privileges and forge protocol packets. So the point is actually we need to actually examine all these vulnerabilities and the weaknesses should be identified and documented to have a secure system actually. That is the point of this discussion. I hope you got some insights on this vulnerabilities, and of course, as I said mentioned earlier, so even though the topic is on vulnerabilities, but the intent of this video is to explain more about them protocols and with a bit of vulnerability and touching a bit of vulnerabilities. Thanks for watching, and if you want to support, you can show your support by either by pressing the thumbs up button or by subscribing, or if possible, become a member. And many people, many of our subscribers are asking how to become a member. So if you have any question, you can write to me. I have prepared a procedure also. I can share with you. Thank you, friends. Take care. Bye-bye.